Welcome everyone, I'm Dan Samiotto. On behalf of my co-authors, I'm presenting R3VAMPs. Now, to produce these R3VAMP actuators and to allow us to change up the geometry very quickly, we are simply using the infill settings of Cura. We've set up a profile in Ender, what's called an R3VAMP in this particular case, but the difference here compared to a regular 3D print is that we have 0 wall thickness and we have 0 top and bottom thickness. We're relying strictly on filling it up with infill only. We've selected a zigzag infill with a 0 alignment, so that keeps everything consistent layer by layer. However, we've got multiple independent blocks where we can take a look at the per model settings, and every second model has that alignment flipped. If I take the slicing and go ahead, we'll see that automatically it produces this type of vamp infill structure. And had I wanted to, if I wanted to change up the size, infill distance to say 8 millimeters, it's a simple matter of clicking that button, running it again, and we've got our new design. Very effective at changing up the geometries. Now, when this infill is placed within a thin polypropylene sleeve, we can act as a linear actuator or artificial muscle when negative pressure is applied. Or if we had actually changed up the stiffness of the sleeve from one side to the other, we can have the exact same infill pattern act as a totally different actuator, in this case, a bending actuator. If we had the sleeve change its thickness across the actuator, we can actually get hybrid motion with part of it actuating and part of it stiffening. And this is shown in a bending stiffness performance test right here, where we have a 5 millimeter thick R3VAMP with a thicker sleeve holding a 500 gram load under 60 kilopascal pressure. Once the vacuum is disengaged, it collapsed and can be rejammed into a new configuration. But because the interior is one large spring, it can return to its original position and then support a load with minimum user intervention.